All right, guys, today's lesson is on perpendicular lines. And the definition of perpendicular lines are two straight lines that intersect or cross to form a right angle, which you should remember is 90 degrees. The symbol for perpendicular is this right here. It is a straight line down with a bottom to it, like an upside down T. That is the notation in geometry used for perpendicular. So here's an example here. In your notes. And I believe in your note packet we have angle 1 here has this additional symbol, which is the symbol for a right angle. So looking at that picture, we're gonna look at this following statements. And we're actually going to start with number 2 here. Number 2 says angle 1 is a blank angle. And again, it has this symbol in your packet, which is a giveaway for it is a right angle. And it measures 90 degrees. Again, that symbol means that it's 90 degrees. If you're working with us in your packet, I believe, let me just double check here. We are on page 52. This is your note sheet. So angle 1 is a right angle and it measures 90 degrees. Angle 1 and angle 4, kind of making connection to the last lesson that we did, these are vertical angles. They are directly opposite of each other of those intersecting lines. So right here, this also, and we could actually mark it up with our right angle symbol. It's a vertical angle, so we can say angle 1 is congruent or equal to angle 4. And so angle 4 is also 90 degrees, or that right angle. Question 3 here. Angle 1 and angle 2, they are supplemental. They are adjacent to each other. They are neighboring angles. And you see this red straight line here at the bottom. When we put them together, it makes kind of a rainbow, which are all kind of indicators of supplemental. Supplemental, when we add them together, equals 180. So if this side is 90, my other side must be 90 in order for that to be a true statement. So for number 3, we know that angle of measurement, or the angle measurement for 2 is also a right angle or 90 degrees. Because angle 2 here is a 90-degree angle, we can assume 3 is also a right angle because of the property of vertical angles, right? They're opposite of each other. So those are 90 degrees. So we know angle 3 also measures 90 degrees. So we just made all of those kind of connections just by looking at that one single start here of a right angle and making connections based on vertical angles and supplemental angles. So looking at that, we have two perpendicular lines. So AB, going back up to question number 1 here, AB is perpendicular to DF, meaning that their intersection right here is a perfect, what I like to call like perfect intersection. It creates 4 90-degree angles. So the big idea at the bottom is if two lines are perpendicular, then they create 4 right 90-degree angles. So those again are all kind of assumptions we can make from that image. All right, so let's take a look at a different image here, a little bit more complex. We've got a lot of different lines here. But as you can see here, we have the statements here that BN is perpendicular to RN. So those are the red lines in my figure. We have line BN right here and is completely perpendicular to RT. So if we were going to mark our right angles, again, that intersection creates right angles. So we're going to mark all of these as being right angles. The second part of the information here says that our black lines, MN, which is this vertical line, is perpendicular to AB. So if we were going to mark all of our angles there, we're just looking at the black lines. Here are 4 right angles. All right, so looking at some true-false questions. Angle 5 is a right angle. True or false? Hopefully you said it is true, because right here, again, those black lines are perfect perpendicular crossing. So all 4 of these we did mark off on the last picture as being right angles. Okay, true or false for this one? Angle 2 is congruent to TON. So here's angle 2, and I'm going to highlight the different parts we're looking at. So here's angle 2, and we want to know if that's the same exact measurement is angle TON. So TON, again, if we list it by letters, it is TON right here. And if I look at their relationship to each other, they are vertical angles. They're two crossing lines. They're not perpendicular lines. We got one red and one black, but they are vertical. They are opposite of each other, which we do know gives you congruent measurements. So that one would be true as well. Okay, taking a look at this, true or false? MO is congruent to OR. So MO, and notice the little line above it. That means segment. So MO is congruent to OR. Okay, so here is OR. Are my two line segments perpendicular? Do they cross completely at a right angle? False, they do not. It is an acute angle. You should see, even if you look at it as an angle measurement, it is a smaller than 90-degree measurement, so that would be false. Okay, the next one here. Angle BTR and angle 6 are vertical angles. So let's first find BTR in our picture. Here's BTR. So I'm looking at that angle, and angle 6. Here's angle 6 up here. Are those vertical angles? True. Hopefully you said that was true. They are opposite of each other. All right, another perpendicular question here. Is my line BT perpendicular to OT? So there's BT, worst kind of tracing there ever. So BT, is it perpendicular with OT? Your answer should be true. They are a perfect 90-degree angle. The only reason why we definitely know that is from that very beginning initial statement about the image saying that our red lines were perpendicular. So I didn't just pick that out of nowhere. That is given in our statement. All right, how about this one? Angle NOB is congruent to MOA. So let's start with NOB. N, here's O, and here's B. So we're looking at this angle right here. All of this in there. Is that congruent to MOA? So there's MOA. Are they congruent? Hopefully you're saying, yes, they are. They are vertical angles. They are opposite of each other. All right, the next one here, I guess they're not really numbered. True or false? Angle 7 and angle 6 are both right angles. Angle 7 is right here. Angle 6 is right here. Are they right angles? True. They are. If you remember back to that initial statement, it said that my red lines were exactly perpendicular, which we know the definition makes these all 4 right angles. So 6 and 7 are both definitely right angles. Okay, the next one here. AON and angle 3 are supplementary, meaning that they're equal to 180. Remember, supplementary is that vocab term that we've been talking about that equals 180. A little hard to tell there. Equals 180. So let's take a look and see where these measurements are. So our first one, AON. So we're looking at right here. And again, those are 2 black lines, right? So we know the measurement of angle 5 is 90 degrees, right angle. And we want to know if that added up with angle 3 is going to give us our 180 value. So here is angle 3. I have a black line and a red line. Those weren't pairs as far as identifying perpendicular intersection. You can also visually see that this is a larger angle. It is greater than 90. This would be like an example of a 90-degree angle, right? So we only need 90 for it to add up to supplementary, so this would be a false. Okay, true or false, 3 and 4 are complementary. So complementary is key to knowing what we're looking for. Complementary are the angles that when we add them up are going to equal 90 degrees. So if we take a look on our chart here, angle or our image, we have angle 3, which is, let me switch colors here. We get angle 3, which is right here. Angle 4 is right here. You should see the characteristic that they form a rainbow or a straight line, which is actually supplementary, equaling 180. It's larger than 90. Even angle 3 alone is larger than 90. So this one would be a false, guys. Okay, angle 1 and 2, are they complementary? So here's angle 1, and here's angle 2. Remember, complementary, we just discussed in that last problem, are my two measurements equal 90 degrees? And in this case, it is a true statement. Right here, these black intersecting lines were perpendicular, so we knew each of these was a 90-degree angle. 1 and 2 are both part of this, if you think of it as like the bottom right section of that intersection. So those would be complementary, so that is true. All right, kind of taking it a step further and using the definitions to find measurements. It asks us if find the measure of angle 1 if we know angle 2 is 48. So we just in the last problem discussed that these two measurements together have to equal 90. So 90 minus 48 would be kind of the operation that we could do. Since it's not necessarily a rounded number, to do mental math. So this would be 90 minus 48 is 52. So the measure of angle 1 is going to equal 52. Because again, we know that these are complementary. They're equaling 90 degrees. So 48 and 52 gives us that value of 90. All right, find the measure of angle 3, which is right here, that obtuse angle. So we know visually it has to be more than 90. If angle 3 is 30. So again, this is 30. We know together these are that rainbow linear pair, supplementary equaling 180. So if we do 180, we take away 30, then angle 3 is going to be 150 degrees. And that makes sense. It's larger than 90. It's an obtuse angle. So again, guys, I always encourage you to think about your logic. Please don't tell me this is 10 degrees. It is a large angle. We definitely know it's some number over 90. Okay, and that's basically it. So this was the notes and review today. We're going to be practicing some more with this skill set. But if you're in class, show me your notes for participation points, and we'll be moving on to the assignment, and you'll get a grade for that as well. If you need any extra help, please just let me know.